Today we're going to continue our Let's Do Some More Problem series from Chapter 5. And I want to go into Chapter 5, Section 3, and start with Question 5. So in Question 5, little f of t is f prime of t, and we're given f of t. Normally, when we're asked to calculate a definite integral with the fundamental theorem of calculus, we're given a function, then we have to integrate the function, that is, find the antiderivative of our given, and then plug in the endpoints and subtract. But in this case, we're given the antiderivative to start with. So really all we're doing is plugging in to the function that we're given. Just to put things in order, if we look at f prime of t, f prime of t would be 8t to the third minus 15t to the fourth plus 3. So here is f prime of t, and this function is not enough space, is the little f of t. So what we're actually integrating, is 8t cubed minus 15t to the fourth plus 3 from -2 to 1. The first thing that we would do is find the antiderivative of the 8t to the third minus 15t to the fourth plus 3, which is 2t to the fourth minus 3t to the fifth plus 3t, and evaluate that from -2 to 1. So what this problem really looks like is the integral from -2 to 1 of f prime, using this information here, 8t to the third minus 15t to the fourth plus 3 dt. And the way we would calculate that is find the antiderivative, which is 2t to the fourth minus 3t to the fifth plus 3t, and then evaluate that from t equals -2 to 1. So it cut out that extra step where we're finding the antiderivative of the function that we're given. So really this problem was just about being a reading exercise, making sure that we're paying attention and not just kind of going on autopilot. So we plug in 1 minus 3 times 1 to the fifth plus 3 times 1. And then we plug in a -2, -2 to the fourth minus 3 times -2 to the fifth plus 3 times -2, and we subtract these two. So I have this function on my calculating machine. So I just entered in this function because I didn't want to type all this out, but for some reason I wanted to write it a bunch of times. I have this function on my calculating machine, and so I just go into the variables, the y variables, the function y1, and evaluate the function at 1. That gives me a 2. And then evaluate the function at -2. And we get a 122. And then we want to subtract these two values. So there's the two values. I could actually have done this all in one. I could have y1 of 1 minus y1 of -2. Any questions? If we want to verify that everything is going right, notice if we put in the derivative, 8t to the third minus 15t to the fourth, oops, 8x to the third minus 15x to the fourth plus 3. If I graph this, wait for it to graph, and then calculate the integral from -2 to 1, we get the -120 that we expect. So all is well. Any questions on 5.3, problem 5? Normally what we would do I'll put this in quotes because they're all kind of normal problems. A normal fundamental theorem of calculus problem would have us find the antiderivative rather than giving us the antiderivative. So for example, we would see something like find the integral from -2 to 1 of, I want to use -2 to 1, say from -1 to 2 of, that was a big change, 4 minus x squared dx. So this would be a normal type of fundamental theorem of calculus problem because it involves the skills of finding antiderivatives. So we would want to find the antiderivative for x minus a third x cubed, and then evaluate this from -1 to 2. This, the problem in the homework, problem 5, you were given the antiderivative and it became a reading exercise. We're not integrating this function, we're integrating the function that's not even stated. We're integrating its derivative. Any questions? Any questions? Great, let's pause the recording here and check out the next problem.